Hi, I'm Kathy Woodard at Echo Lake Elementary, and this is my 5th grade class, and we're doing math today. So let's find out what we're going to learn. Let's pull from the Cactus of Equity. Olivia, can you read for us our first learning target?
I am learning that any number can be represented as a fraction, decimal, or a percent.
That's right. And read for us our second learning target, Peyton.
I can determine.
Oh, thanks, sir. Go ahead.
I can determine
Equivalencies.
equivalencies among fractions, decimals, and percents.
Yes, I made that word green because that is a strange word. Raise your hand if you can see any root words in equivalencies. Ash.
Equivalent.
Equivalent. And anything else? Kayla.
Equal.
Equal, that's right. Equivalent and equal. So what is our guess about what equivalencies among fractions, decimals, and percents means? Emery?
Like equals?
Yeah.
Equal to each other?
That are equal to each other. Exactly. Yes, yes. So, all right. So you remember last week we did a poll. A few people were absent, so we actually only had 22 of you voting. But people chose what were their favorite fruit. And that was so that we could bring in fruit today for our math experiment. And so I took this data and I put it in a spreadsheet. I put down, many of the fruits only one person chose because you had a lot of variety. But mango was the most popular. 7 people chose that. Oh, sorry. Pineapple, there were 2 people, and watermelon, there were 3 people. So when you see on the spreadsheet, what do you think the spreadsheet, I made a formula and told the spreadsheet what to do to change the fraction to a decimal. Alicia, what do you think the spreadsheet did to change this fraction to this decimal?
Divided.
That's right, because what does the line in a fraction say, Liam? 1 what 2?
1 divided by 2.
1 divided by 2, that's right. So I made a formula to tell it to do that and did it for all of them. And then I made another column to change it to a percent. And Aveline, what do you notice is happening from the decimal to the percent?
You move the decimal twice to the right.
Yes, exactly right. Great job. And so you can see here's all of our data here. Why do we have so many pie slices that are exactly the same size, Pippa?
Because a lot of people chose fruit and a lot of them were just one person.
A lot of them were just one person, that's right. And you can see here, 7 what turned out to be, out of 22 turned out to be 31.8%. Actually, technically, let's take a look at this. If we had this, boys and girls, how would we really write this decimal? Because right here it's getting cut off because it keeps going. So does anyone know how we can show that when a decimal keeps going? Peyton.
So it keeps on repeating 18, so you put a line above the 18.
That's right. So really you would say 0.318. And does the line go over the entire thing, boys and girls?
No.
Now, what part does it go over?
18.
Just 18, because that's the only part that repeats. Very good. And then when we jump twice to the right, boom, it turns into 31.8%. But really? Is it 31.888888?
No.
What would we need to really put here to have this be correct? Yes.
8-1.
8-1 in the line over both of those. That's right. I think what they did in this program is they rounded, because if you rounded with the 1 being after the 8, it would round to 8, right? All right, so let's continue on. Let's talk about our wrap before we do it. Now, you guys know we did the wrap the other day. Raise your hand if you're going to participate with me again today. Awesome, or if you didn't before, you can today. Great, so let's talk about what the parts mean. So first, it says you should know that when you multiply or divide by 10 or any power of 10, it makes that decimal jump to the right, multiply to the right, divide to the left, and so forth. So what does that part mean? Let me see if I can call on someone. Scott, what do you think that means about when you multiply? How about this? When you multiply or divide by 10 or any power of 10, what are powers of 10, Scott?
Any multiple of 10. No, 10, 1,000.
10, 1,000.
10, 100, 1,000.
Yes,
1,000.
exactly, that's right. And so you're going to jump to the right. If I was multiplying by 10, how many times would I jump to the right, Kendall? If I'm multiplying by 10. Let's see what 10 looks like. if I'm multiplying by 10, it has 1 0. So you jump to the right one time, right? Yeah. And Ellen, what if I'm multiplying times 100?
Then you would move the decimal 2 places.
2 places, that's right, because 100 really is 10 times 10, right? So you're going to jump 1 time each time you multiply by 10. What if I'm multiplying by 1,000, Christopher?
You would jump 3 to the right.
3 times, that's right, because 1,000, who remembers how we could say 1,000 as an exponent, a power of 10? 10 to the, Cleo.
10 cubed.
10 cubed, exactly. It's 10 cubed, which means 10 times 10 times 10. So you're multiplying by 10 3 times, so you jump to the right 3 times. And if you divide, instead of moving your decimal to the right, Aishwarya, what do you do then?
You move it to the left.
You move it to the left, that's right, so it's getting smaller. All right, now let's think about this part. We just said that, to the right for multiply, to the left for divide. So fraction to decimal, numerator in the house. What is the numerator, Spencer, in 7 20-seconds?
7.
7, that's right. And does anyone remember what that fraction was for, which fruit had 7 20-seconds? 7 people liked? Pratham?
Mango.
Mango. In fact, you brought mango today, didn't you? Yeah. So 7 goes in the house, 22 is going to be outside the house. That's kind of an ugly looking divisor, isn't it? We're going to have some even crazier divisors today, because your divisor is going to be the mass of your entire piece of fruit, or the entire part of the fruit that you're weighing. So there are going to be some crazy numbers with 2 digits, maybe even 3 digits. So that would be annoying to do with pencil paper. So instead we're going to use our Desmos calculator to divide. Okay?
Yay.
Yeah, I know, you're very excited about that. If it was one that had, a single digit outside the house, we'd just probably do it on paper and pencil, because that'll be just as quick. When we divided, we got this. And then it says decimal to a percent, twice to the right that decimal went. So do you see it going twice? Okay. And changing into 31.81 repeating percent, like you all just said in the last page. And then here, back from percent to a decimal, 2 to the left, that decimal's pulled. We're not going to be changing them from percents back to decimals today, but sometimes you will do that. And we also, remember we learned about the ABCs of DNP to help you remember with that, right? Yeah. Okay. All right, so do you all feel ready to do the rap?
Yeah.
All right. Let me turn on the music. If you are doing the rap, stay up here. If you are not doing the rap, go further back in the audience, okay? And be good listeners.
Scared.
All right. And you all can face this way so you can see the words. I'm going to face this way so I can see you all. And also, I sort of know the words now, so, all right. All right, are you ready? Okay, here we go. You should know that when you multiply or divide by 10 or any power of 10, it makes that decimal jump, multiply to the right, jump, divide to the left, jump, multiply to the right, jump, divide to the left. Like this one has 10 as a base, you better notice where that decimal's placed. When you multiply by a power of 10, that decimal jumps right again and again. Inversely, when you divide to the left, that old decimal slides. Fraction to decimal, numerator in the house, divide. Miggity math. Decimal to a percent, twice to the right that decimal went. Back from percent to a decimal, 2 to the left, that decimal's pulled. Jump, multiply to the right. Jump, divide to the left. Jump, decimal to percent. Jump, percent to decimal. Woohoo! Nice job, guys. You're awesome. Wow. Yeah, we learned that on Wednesday, and you guys are awesome. I feel like you know it as well as me, and I've been doing it already more years, so you guys are really good. And
We heard it during the tornado drill. So.
that's true. I did perform it during the tornado drill. I ended up getting applause from all of 5th and 4th and 2nd and whatever other grade was down there. 1st, maybe? Yeah.
All the grades were down there.
Yeah, a lot, yeah. Even children were in the bathroom cheering, right? So, and Alicia, weren't you telling us on Wednesday that since you are a dancer, you might
Yes,
make some choreography for the other parts of the song?
Yeah.
That would be really cool. Hey, maybe you could perform that on our reward day where we're having America's Got Talent.
Yeah.
In fact, Mrs. Black asked if we could come perform it for her class. Because they're learning about presents too. Yeah, yeah. So pretty cool. All right, so today, this is the exciting part. Everyone's brought in fruit, and we've got it ready. So again, we have our same learning target, but we're going to do it with fruit, right? So we're going to find out what percent of each fruit is edible. So first we need to think about some of these things. What does edible mean? Liam?
Able to eat.
Able to eat, that's right. So there'll be part that we can eat and part that we would like throw in the trash or maybe put in a compost bin, right? So you'll write down the name of your fruit. You're going to have a chart where you can write down if you do more than one or people at your table do another one, they can. I want you to make your hypothesis of what percent of your fruit is going to be edible. I think Alejandro already has a hypothesis for his blackberries. What is it?
100%.
Yeah, I'm pretty sure he's going to be correct on that.
I think for me it's 100% too.
So, huh?
I think it's for me it's 100% too.
You can eat the seed of the mango?
No, like it's
Huh?
You can eat
no,
the skin.
the skin.
Oh, but the seed is part of the mango that you can't eat, right? So that will be part of the trash, yeah. So that's a good thing to think about. So Alejandro, you'll also want to write down some of the data that other people at your table gather, okay? Yes?
Mine might be because the seeds are edible and the skin is edible, so
Ooh, wait, what's yours again?
pomegranate.
Pomegranate. Even the outside skin you can eat?
I think so. No.
No, I think that part you don't. So that part, see, we're going to find the mass of our whole fruit. So before you start eating, you're going to put your fruit in the balance scale and find the mass of it. So you'll have to take turns because each table has a balance scale, but there's 4 people at each table or 5. Then you can eat it, and then you'll put the part you didn't eat it back in the balance scale and find the mass of that trash, okay? So then the mass of the part that we actually ate, it's gone, it's in your stomach. How are we going to find the mass of that? Christopher?
So the mass of the whole fruit, you would do that minus the mass of the trash.
Exactly, because it's already in your tummy, right? But if you do this minus this, the part that is left over is going to be the part you ate, right? Yeah. So that'll find the mass of the part you ate, and then what will you put, what of these numbers, mass of the whole fruit, mass of the trash, mass of the part we eat, which of those will you use to see what fraction of the whole thing was edible? Let's see if I can get some message on chat. Rahita? So remember, a fraction is a part out of a whole. So what will be our numerator on top if we're wanting to know how much we could eat? Will it be the part that we ate or the part that was trash? If we're wanting to know how much is edible, you want to call a friend to help you out?
The mass of the part that we ate.
Yeah, so the mass of the part you eat will go on top, and we're calling that E for the part we eat or that's edible. And then what will be so that's the numerator, what will be the denominator of our fraction? Liam?
The mass of the whole fruit.
The mass of the whole fruit, that's right. So on your paper, it also shows you this in case you forget, E over W. So the part you eat, that's the numerator. The whole thing is the denominator, which makes sense because fractions are part over whole, right? And how will we change that fraction to a decimal? Once we have this fraction, how will we change it to a decimal? Oh, I did have Henry already. Jeff, what will we do once we have something over something for our fraction? How will we change that fraction to a decimal?
We divide the numerator by the denominator.
That's right, that's right. I'm sorry, I was looking at your twin brother. Yes, you divide the edible divided by the whole. And we're using our Desmos calculator because we're going to have some crazy numbers, right? Mathematicians think about what the problem is and whether it's a good problem to use what tools for, pencil and paper or a calculator, right?
Why don't they use calculator all the time? Why don't they use calculator all the time?
That's a great question. Why do you think we don't use calculator all the time? Why would someone choose to not use a calculator? Yes,
So you
Spencer.
can learn how to work them out.
So you can learn how to work them out, and that helps you have a better understanding, so when you're doing a close to cloud, right, you'll know if things are making sense or not, because you've learned how to do it. Emery?
Maybe while you're solving it, you find out different ways to solve it.
Oh yeah, you know how we said there's many ways to solve problems and you want to pick the way that's working best for you? So, yes?
If you don't know how to like change like maybe a fraction to a decimal and you're trying to put it into a calculator, you won't know what you need to type into the calculator.
Ah, yeah. And you also won't know, like, if you get one of those crazy answers that doesn't make sense at all,
Yeah.
right? Like, remember we had 7 over 22?
Yeah.
Think about that. If you have 7 over 22, is that more than half or less than half? Less than half. So knowing how to do the math first yourself helps you, because like half of 22 would be 11. So 7 over 22 is going to be less than half. So it helps you to think about it, you know. Also, sometimes you are doing math in the real world at the store, and if you can do it quickly in your head, it's actually faster than with a calculator. But if you had a crazy thing you're dividing by, even if you're out of the store, you'd be like, let me take out my phone and use my calculator, right? But if you had something that was easy, you could think it even quicker, then you could take out your phone and put it on your calculator, right? Yeah. That was a great question, Liam. Drew, how will we change our decimal to a percent? So once we have our decimal, how will we change it to a percent? Oh, you can tell me. Or you want to call on a friend to help you?
So you move it to, you multiply it by 100.
That's right, and that moves it twice to the right. Excellent, nice job. Yeah, you multiply by 100, which is jumping the decimal place 2 places to the right. So I'm going to snowflake this and leave it up here so you can see while you're working. But does anyone have any questions about our procedures for our experiment? No? No? Okay. All right, well then move back to your seat, and I'm going to have someone hand out the papers so you can record your data. Are you sure you don't want any more of the heavier ones?
Yeah, we tried 400.
Okay, 300. 300. Okay.
50
grams.
350?
350.
It's not even moving. It's about 370.
370.
Okay, 370.
Oh.
That's 400.
So that was too much?
Yeah, we already tried 400. That's too light.
Oh.
Put a 10 back in. One more, another 10.
So if this 10 grams was too much, what should you try?
Try 5.
5 grams, okay.
Oh, just a little more. Just a little more. There's one more. There's 2 more. Okay.
8.
There you go.
All right. So how much was that? You can take them out and count them if you want.
Something 9.
I know it's about 380.
Move these so they don't think that's part of it.
That's we didn't do it. 300. 200. And that's 300.
We didn't do it. 360, 370, 385, 79, 76,
379.
379? All right. So everyone can record that on their sheet, even if you're not the one eating it.
It was so tempting to eat earlier.
Yeah.
And do you have a pencil?
When you are eating it, make sure you only weigh the trash to this part, not this part, since you only weigh this part. Sorry, okay? So what have you all,
We did his
the blackberries? Did you do all the blackberries?
I just did one.
Just one, okay. And how much did it weigh? 8 grams, okay.
By the way, is it okay if I just do this one because they
Yeah, sure.
really sad?
Yeah. That would be another interesting experiment. You could weigh each blackberry and then find what is the average mass of a blackberry.
Yeah, I don't want that. Since it's like easier, can I do that?
Yeah, I mean, yeah, because that would be fun. You could do that on the backer paper. But let them weigh their whole fruits first, okay? That would be really cool. Do you know what math you would do to find the average or mean of the mass of the blackberries? No? You would add weigh each one separately, add them all up, and then divide by how many. That gives you the average of many.
You can take it out.
Yeah, just take it out. Don't
Miss Woodard, what does it mean by mass of the trash? Because it's not really any trash. It's not apple.
It's the mass of the part you don't eat, basically. Yeah.
So don't eat.
So like the stem and the seeds, or the part of the core that you don't.
So I can eat it?
Yeah. So now, wait, you found the mass of the entire thing first. All right. So now you can eat, and then you'll find the mass of the trash. Yeah, that looks very balanced. What was its mass?
Let's do the one. Let's eat. Well, no, 205.
Oh my God. Guys, you can put 205 grams for Kendall's banana. So then you should record the ones that you're not eating as well.
Oh, so we're doing the one that
Then,
we're not going to eat? Okay, I'm going to eat all of this.
then before you do your persimmon, can you write down the banana?
Can I do the orange? I brought this in.
And put 105.
Okay, look, it's a
Two-
heavy orange.
205 grams. Yeah.
Okay, I'm gonna start with.
Yeah. How much? What percentage of her banana do you think will be edible?
So let's try 30.
Well, this is my
50.
This is my 3.
Is the back of your balance touch? Can you move that box away a little bit? I feel like, yeah, there we go. Okay, and then it was 205. The whole thing.
70.
Yes.
Wait.
So now you can find the mass of your persimmon.
It's gonna be close, guys.
So put all of these pieces in first and find the mass. Maybe come over between them to do that.
That's a decimal.
Ah, so where is the decimal hiding in a whole number? Yeah, so if it jumps, so yeah, 1.0, and then if it jumps twice, yeah. In fact, add a 0 here and do those 2 jumps to show how that would work.
We need one more.
Isn't that cool? Oh, no, starting from decimal, then jumping to the right, yeah.
Add these and
Wait, I think he's doing all of these pieces, Kendall, because he's doing this whole thing. Yeah.
You add all the pieces.
Yeah,
Now we need to wait for it to stop moving.
Starting here and jumping twice to the right.
Yeah, it was fine where it was.
Okay. So, whose fruit are you doing right now? What is that?
Orange.
An orange? Okay.
It's even? I think it is. Yeah. You done?
Okay. And now time for the heavy part.
So now we're going to add it up.
20, 30, 40, 50, 60, 70, 71.
Everybody write down orange and put her total mass, but also make a prediction for orange of what % you think is edible. Yeah, just only what you subtract from one slice of it.
That's 50. Yeah, whatever these.
Cool. And do you eat the whole inside part, or is there a seed in the middle? Okay, so then when you weigh the trash, you'll weigh this plus the seed, right? That's really cool. Or basically any parts you don't eat, you'll weigh when you're done. Oh, did you not weigh it ahead of time? You did? You weighed this one ahead of time? Okay.
It's 75. I know this. I don't need to.
Oh, yeah, let me get napkins. All right, hold on, I'll be right there.
Let's just do one for 28. Let's dive in.
Right, so he'll eat it.
60, 70, 80, 90. So do we do
But he is eating that whole piece, right?
Okay, I can use Is this white part?
What? How does that make sense?
You can put the mass. This is 345.
Okay, which part are you eating? Okay. Oh, and then that part I could cut and they can eat. This part will be this one.
What do I have to do? Like the math?
Calculator.
Who's next?
Yeah.
Olivia. Wait, did you write them a show? Okay, you need to start on those.
Okay, so then you can put those parts in there. And if other people want to eat these other parts, I'll
Okay, are you okay? Alright, it's between you and Emery. What is the first thing go?
Okay, so you have to eat a whole lime.
I have to eat this. I'm scared. I'm actually scared to eat
I can see the seeds in it.
You don't have have to if you want to.
I know. I'm
Crazy number like that.
Oh, yeah, this is a weird. I would say you could leave it like that, but maybe if it kept going, put like a squiggly equal sign in front of it. And then for percent, I would jump twice to the right. And then maybe just say it rounds to 58.5. But put the squiggly equal sign for that. Because, yeah, that doesn't even look repeating. That looks just like more crazy stuff happening, right? Yeah. So, take a look at your data. And what I'm wondering is, were there any that surprised you because they were way more or way less? Aveline? Which fruit?
For the pineapple,
Yeah.
I had only actually ended up eating 6 grams out of 176.
So what percent was edible then for you?
3.409 repeating.
Wow. So she only ate 3% of that fruit, right? Yeah. Who else did pineapple? Let's compare, because I think you ate an especially tiny bit of pineapple. But let's see what other pineapple percents were edible. Yes.
So my hypothesis was 75%, but here's what percent I actually got.
Yeah.
I got 27.4%.
Wow. Wow. And Alicia, you were with a different group. Tell us what you got for
Our
pineapple.
hypothesis was 60% for the pineapple,
Uh-huh.
but we ended up getting 24.7%.
Wow. Wait, you had 24.7 and you had what?
27.4.
Those are pretty close to each other. Okay, let's hear some more people who had pineapple. Ash.
I had an apple.
Oh wait, can we do pineapple first and then come back to other ones? Because I just want to why do you think we're wanting to compare all pineapples first? Kayla?
Because most parts of pineapples aren't edible.
Okay. And also, what have we learned about in science when you try something again and again? What do we call that in science? Alejandro? Repeated trials. That's right. So we can see if there are outliers. So we had about 3%. We had 24.7% and 24.
27.4.
Oh, 27.4 and 24.7. So right now, does it seem like we have any outliers so far? Yeah, Aveline's an outlier so far. But did anyone else measure pineapple, or was that all the people who did pineapple? That was all? Okay. Oh, you also did pineapple?
Yeah, we did pineapple, we didn't finish it.
Okay, so after you finish it, we can compare and see. So that's interesting. Yes.
I just say I'm pretty full right now.
You're pretty full right now.
There.
Good, good. Okay, so Ash, you did a regular apple. What did you find?
I did a pineapple also.
Oh, you did pineapple. Okay.
I didn't finish it.
You haven't finished pineapple, but you did an apple
Yeah.
and finished that?
The
And-
whole fruit was 46, and the only trash was 2%.
Wow. Who else did apple? Pippa, you did apple, right?
No, I did that.
Oh, that was that apple. Yeah. Yeah, she ate almost all of that apple, so she only had how much was edible then? Was it like, what percent was edible?
44.
Yeah, but what percent did that turn into?
95.7.
95.7%? Yeah, yeah. Wait, let's think about money being spent on fruit. Do you think that percent of fruit edible has any impact on our spending of money on fruit?
100% no.
How do you think that could have a real world consequence for us? Olivia?
So if you buy a fruit for let's say $7, but you can only eat a tiny bit of it, it's not worth buying it.
Ah. So are all fruits the same amount of money per pound? No. So you kind of really have to compare that, but then also be thinking in the back of your mind, what percent of this fruit will I actually eat? So part of that I'm paying for is something I can't eat, right? Yeah. Okay, who else wants to share? Olivia?
So we thought the cantaloupe would be 70% edible.
Okay.
It's actually only 42%.
Wow. So that was another one where there was less than you could eat that you thought. Okay. Peyton?
Ours was sort of based before we did orange. We got 75% as a
Hypothesis? Okay.
and we got 60% as an actual percent.
Okay, yeah, that was close. How about other people who had ones that were pretty close? Anyone who hasn't gotten had a turn yet? Christopher?
Mine wasn't pretty close to percent, but I just wanted to
Oh yeah, tell us.
share. I did a line, and
Okay.
my hypothesis is that I'd be able to eat 50%,
Okay.
but I could only eat 35.7%.
Ah, that's interesting because when you think about how you eat a lime,
Yeah.
describe what you do when you're eating the lime. Yeah, you're like He was saying you're kind of slurping the juice out of it, biting and getting the juice. Yeah, yeah. Liam.
That fruit.
Yeah, the rambutan. I'm not sure how to say it. It was from, what did it say? It was from Bolivia or Brazil? Guatemala? Guatemala.
Yeah.
Okay. And yeah, so what % of that was edible? I mean, your prediction was,
77.
yeah, and then how much was actually edible?
34.
Well, that was the whole fruit, and you ate 19 out of 34, but what % was edible?
Oh, 55.8.
55.8%. What were some of the parts looking like that you didn't get to eat in that fruit?
The seed in the outside.
Yeah, so it had like a porcupine looking outside and a seed in the middle. And you
Oh,
could eat
it's
those
like
parts.
coronavirus.
That's disturbing. Okay, so you all did a really great job, and our lesson is over, but I am gonna let you have more time to explore that on your own. Thank you for watching. We hope you enjoyed our math lesson today.
4